Well, I'm excited for this session here. We've been talking this morning, the plenaries were about theology and philosophy, gave us a good grounding. Now we're going to talk about science. Wow, it's going to be cool. I'm excited to be here with my friends, Jennifer Wiseman and Steve Freeland. Friends and fellow scientists, we're here to talk about life beyond the earth. What would it mean for Christians? So there's a lot of cool science. We're going to hear first from Jennifer talking about planets beyond exoplanets everywhere, and just enjoy some of the wonder of God's creation. And then Stephen Freeland is going to share about astrobiology and how that is growing, what do we know about life and how it first got started. And then I get the theology part at the end. Oh boy. So these discoveries have sparked a lot of curiosity that ties into the big questions of, are we alone? What does it mean to be human? And so it's a really cool laboratory to consider those questions as we consider life elsewhere. I bet a lot of you are fans of science fiction. So this time now we get to actually relate science fiction to Christian theology. So our three talks in this session, I think we will just go ahead and get into it. So first up is going to be Dr. Jennifer Wiseman. Jennifer and I have been friends for over 25 years. I guess that says we're old. Are we old? I don't know if we're not old. We met as graduate students. We were both involved in InterVarsity Christian Fellowship. She was earning her PhD at Harvard University, and I was working on my doctorate at MIT. We were both studying astrophysics, and at that time we were both studying at radio wavelengths using radio telescopes. Since then, we both branched out into other wavelengths of astronomy, optical and infrared and things like that. We both love the wonder and awe we see out in the universe and how that relates to our Christian faith. Jennifer has gone on to be a leader in multiple scientific organizations and has also been a leader in science and faith organizations. She is currently the head of the Dialogue on Science, Ethics, and Religion at AAAS. They have a table out in the lobby. I encourage you to check it out. They're doing a lot of great work in the public square context and in the university context, and also with seminaries. So definitely worth checking out. So I'm excited to introduce then Dr. Jennifer Wiseman.
All right, thank you very much, Deb. Yes, it was fun being in graduate school right down the road from where Deb was in graduate school, and us getting together and finding out that we had a lot of things in common, and to walk as friends all the years since. So that's been a blessing. And one of the things that happened while Deb and I were in graduate school was an amazing transformation in our field of astronomy. Because when I started graduate school, we didn't know of any planets outside of our own solar system. I mean, we knew about the planets in our own solar system. We expected that maybe stars other than our sun might have planets. And of course, we'd all seen plenty of science fiction where that was the case. But there hadn't been any detections. It's very difficult to do those detections. That all changed during the years we were in graduate school. The detections began, and they've been just exploding ever since. So that's what I'm going to give you a little overview about in my 19 minutes I have left. Whew, okay, so we got to hurry. But before I talk about exoplanets everywhere, I need to tell you that there are stars everywhere. There are lots of stars, all right? And this is one of my favorite images. This is a calibration image that was taken for one of the more famous telescopes, the Hubble Space Telescope, its newest camera. And it's so beautiful that I show it off. But this is a wonderful collection of stars inside the middle of a globular cluster in our own Milky Way galaxy. And you can see that stars are different from each other. They're different colors, they're different brightnesses. And if our sun were in a crowded cluster like this, it would look like one of the smallish, yellowish stars scattered about the field. We've also learned through our telescopes that the galaxy is very active, that stars are actually still forming and coalescing out of interstellar clouds of gas and dust. When massive stars form, they will ionize or light up the gas around them, and we see these beautiful nebulae often around the spaces where massive clusters of stars have recently formed. And the way we're finding out these things is through the tools of astronomy. The technology has developed very quickly over the past 4 centuries since Galileo, and especially the past few decades, so that we have different kinds of telescopes, and we need them all. So here's some examples of telescopes we use to study all kinds of things in astronomy. We have telescopes in space that are above the atmosphere, and so therefore they are able to get better, sharper images. We have telescopes on the ground. A couple examples there on the lower left are 2 telescopes on the top of what we hope is a dormant volcano in Hawaii, and an array of radio telescopes on a high elevation plateau in South America that's able to pick up that radiation that comes from deep within these interstellar clouds of gas and dust where stars and planets form. And by using different kinds of telescopes with their different unique capabilities, and then combining that information, we get a much better understanding of what we're studying, whether it's stars or galaxies or planets or exotic things like black holes or the interstellar medium. And we can see the beauty of how all these different things in space work together. Now, stars and the interstellar gas and dust between them and a lot of dark matter that we don't see fill the volume of what we call galaxies. So galaxies are these collections of stars, gas, dust, and dark matter that are held together by gravity. And you see a couple here. One of them is they're both spirals, but one of them you see kind of more face on, and the other one you're seeing kind of more edge on. We think that our own Milky Way galaxy that our sun is in looks something like this. But we can't get all the way out of our own galaxy to look back and take a selfie of it just yet. So we have to learn what we learn from kind of looking around on the inside. But I think spiral galaxies are beautiful. So each galaxy can contain something like 200 billion stars. There's so many stars, the light kind of blends together in the middle there. We think a lot of these galaxies have supermassive black holes in the middle of them. That we can't see, but we can see material swirling around and into them. And here's an artist's conception of our own Milky Way galaxy. So our sun here would be along one of those spiral arms. You see our solar system. So our sun is just one star amongst hundreds of billions in this galaxy, and our planets, like Earth, are orbiting that one star right now, and of course all the stars are orbiting around the center of our galaxy. So that's where we are right now, along near one of these spiral arms. Can you feel it? We're moving and grooving, all right? And here's a representation of our one star, our one little star, and the planets orbiting that star, our sun, Mercury, Venus, Earth, Mars, Jupiter, and the rest. And this is not to scale, by the way, but you get a sense. And of course, the planet we're most familiar with in our solar system is our wonderful planet Earth, with its solid surface, its oceans, its clouds, and its life. And of course, we wonder, and humans have wondered as long as they've looked up at the sky, are there other planets in the universe? Are there other worlds like our own? And then we ask, of course, the next leading question, is there another Earth out there, a planet like Earth, and could there be life on other planets? We know now the answer to that first question. And it's absolutely yes. This is an artist's conception of a real planetary system that was discovered a few years ago using the Kepler Space Telescope. It's a star that has, in this case, 6 planets in tight orbits around that star. We're finding a lot of systems like this. And we're also finding the regions around young stars where planets are still forming. So here's an example of a circumstellar disk of dust. It's taking the form of rings around a young star. And this ring system is heavy in dust and solid particulates that can actually coalesce and form planetary systems The diameter of this thing would be about the diameter of our own solar system around the inner star, detected by this ALMA millimeter and submillimeter wavelength observatory in South America. All right, that's a pretty picture, but we don't quite have the capability of taking these beautiful images of other star systems yet. It's very difficult. So how do we detect exoplanets? An exoplanet is a planet outside of our own solar system. We have to use these clever detective techniques that astronomers have developed. The most straightforward thing, as I said, would be to just take a picture, wouldn't it? Can't you just point your telescope and take a snapshot and there you go? Well, this is very difficult because stars are very bright and you need to suppress somehow the starlight. Otherwise, the little planet gets lost in the glare. It's kind of like looking at a lighthouse to find something that's a billion times dimmer lost in the glare, like a firefly next to a lighthouse, all right? That's the challenge of trying to take a picture of an exoplanet around another star. Nevertheless, we're working very hard to improve what we call light suppression technology to be able to do that. And here's an example of a successful image of 3 exoplanets orbiting a star. The dark circle there is the star being blocked out by what we call a coronagraph. And in this system, the planets are far out away from their parent star, so it made this possible to take this kind of image. And future telescopes that astronomers are eagerly designing will be better able to do this kind of light suppression. It's not as straightforward as just putting a little circle in front of the star. Light does funny things like bend around edges and stuff like that. So it's really quite a sophisticated technology that has to be developed. All right, so if for most of these systems we can't just take a snapshot, a picture right now, what are other ways? Well, one is that we can look for tugging motions on the star. So if we can't see the planet, we might be able to see how the planet and the star are gravitationally interacting. Because it turns out that as a planet orbits the star, they're actually both orbiting something called the center of mass. And so that means that the star wobbles a little bit while planets are orbiting in that same system. If we could get away from our solar system and look back, we could see that our sun is kind of jostling around a little bit due to the mutual gravitational interactions of the sun and the planets. And so we look for this effect on stars to see if they wobble, and that's how a great many of the first exoplanets that were detected was by looking at stars. And it turns out as something moves towards us, the light we receive is a little bit bluer than as it was emitted. And as it recedes away from us, the light we receive is a little bit redder than it was when it was emitted because of the relative motion of the object and the observer. And so we can see this effect. If a star is wobbling, the light will shift a little bit, blue, red, and that regularity will tell us the mass of the object that's pulling on it, although we don't always know the inclination of the system, but we can get some estimate of the mass. Another technique, an indirect technique, is to look for the starlight dimming if a planet happens to be orbiting along the line of sight. So if we're looking at a star system and there's a planet that's orbiting that star and it happens to be orbiting in front of that star, we can see the total starlight kind of dip a little bit as this happens. So here's if I can make this work. Yeah, so here's an example. The planet's going in front of the star. That little graph shows you the total amount of light that we see from the star. And it dips a little bit when the planet is blocking some of the starlight. So this is called the transit technique, and it's very popular right now. We have discovered many planets this way simply by seeing regular dips in the total starlight flux that we're getting. And also, we look at the light that's coming through the outer limbs of those planets that are transiting, and some of that is absorbed by the outer atmosphere of that planet, and we can tell something about the composition of that planet's atmosphere through this transit technique. All right, you've seen that now. I should just mention that the Kepler telescope discovered thousands of exoplanets using this technique by just staring off at 100,000 stars in the galaxy and watching which ones of them had these periodic dimming, and then we had to rule out some other explanations for them before we could confirm that some of them were actually exoplanetary systems. We have another space telescope now called TESS that's looking at nearby star systems and again, looking for transits and studying the population or trying to find out how many of the nearby bright stars have planets. So here's a histogram showing from the early 1990s, when exoplanets were just starting to be detected, up to this year. And this is the cumulative number of detections of these planets outside our solar system. So you see it's basically zero when you get to start in the late 1980s, early 1990s, starting to detect them by onesies and twosies. And then they grow, and if you have really good eyes, you can tell there's different colors on this histogram. It shows you the different techniques by which these different exoplanets were detected. Most of them in recent years by this transit technique, some by this radial velocity or the wobble technique that I mentioned, and a few by some of these other more exotic techniques that we can talk about at the aquarium tonight as we're looking at fish, okay? So I just want to show you this explosion. So from knowing nothing to knowing about thousands of exoplanets just in the last 2 or 3 decades. So we live in a really interesting time in human history. And not only that, but we can actually do some statistics now of the kinds of planets that these are, how big they are, and how common they are. And so we can now say that planets are actually common in the galaxy. We can now infer from the sample that we have that on average, every star probably has one planet. So some will have more than one, like our sun, and some don't have any, but most stars seem to have a planet, statistically speaking, at least. And if there are something like 200 billion stars in our Milky Way, that means something like 200 billion planets, right, in our own galaxy. And then we think there's at least something like 200 billion galaxies in our observable universe. So other galaxies, they could have a lot of planets too. So we're talking about a lot of exoplanets, all right? Now, are they all full of life? Well, probably not. Most of these planets are not in the right place to have advanced life as we know it. They're either too close to their parent star, so they'd be too hot, or too far away, they'd be too cold, or they have weird orbits, or their star is flaring a lot, or something. But we don't really know exactly the extremities to which life can survive. And so we're just starting this exploration. And I should say that, we were so thrilled to find all these planets around stars far away in the fields that the Kepler telescope looked at. But then we happened to find that our nearest star, the nearest star to our sun, the nearest star system is the Alpha Centauri system. And one of the little stars right next to Alpha Centauri is called Proxima Centauri. Very close, nearest star to us. It's a tiny little star in the bottom right of this picture. And Proxima Centauri has a planet that's kind of sort of Earth-sized and kind of sort of, and we call the habitable zone around that planet. So it's a very interesting candidate, and it's right in our neighborhood, so to speak, just 4 light years away. Now, we don't really know what it looks like, but that doesn't keep us from imagining. So here's an artist's conception of what it looks like from Proxima Centauri b, from that little planet. And we're discovering all kinds of interesting planets, even though we only have a little information these days. So the TRAPPIST-1 system, for example, this is not to scale by any means, but is a small star with several planets that seem to be more or less Earth-sized. A lot of the first exoplanets we detected were very big, like Jupiter or bigger, and they were orbiting really close to their parent star, so they would do a complete orbit in just a few days and be very hot. But now we're able to detect planets that are more temperate and more Earth-sized. This is an artist's conception of what these might look like. And we haven't actually stopped looking in our own solar system for interesting places for life either. This is Europa, the moon of Jupiter, and it's an ice-covered moon with cracks in the ice, and lately we've been detecting plumes of water vapor that are escaping between those cracks. We've always thought there might be an ocean of liquid water heated from the inside underneath this ice. And of course, where there's water, we wonder if there's life. Now we may be able to study that water from outside the ice, at least at first. All right, these exoplanets, though, most of them are very far away. So how are we going to know if they are supporting life or have life when we can only look at them remotely? Unfortunately, we don't have warp drive yet. We cannot go to these other star systems and look with our hands and feet. So we have only remote sensings. We can look at their atmospheres and analyze the composition of the atmosphere and then look at the mass of the planet, its orbit, and put all this data together. We will do what we would do if we were trying to see if there's life on Earth from afar, and we would find signs of life here through looking for biosignatures, like evidence of oxygen in our atmosphere, which is replenished by the life on planet Earth. We'd look for evidence of liquid water in the atmosphere. That's not a proof of life, but it can show habitability. We'd look for the whole spectrum reflecting off the planet to see if it shows signs of life. We'd even look for other molecules like methane on planet Earth. Cows emit a lot of methane, and so we might find a bovine planet somewhere else. But then we would have to rule out other explanations for these things. So it's probably going to be a slow process before astronomers have any strong sense of unity on whether we've found another planet that's harboring life. And of course, we might look at a planet that's the same size as Earth and similar to Earth, but maybe at a very different stage from Earth, a different age of our Earth. Our Earth's atmosphere has changed over the last 4.5 billion years. From the early days, it had a much higher level of carbon dioxide in the atmosphere, and now it has a much higher level of oxygen. And life has been interacting and affected by all of this, but we do see very primitive life in evidence from Earth from its very earliest stages, just 1 billion years. Stephen will tell us more about that. But what would we look for on another planet that might be at another stage? And what if we find life? I am transitioning now kind of as a preview to Deb's talk to some of the non-science, but the very interesting philosophical questions, theological questions that come. How would society respond to the detection of life? Or conversely, to the realization that maybe life is very hard on the types of planets that we're finding. And even if we find evidence of simple life, it would show that however life began here, it began somewhere else. How's society going to respond to that? And of course, we're all curious about complex, intelligent life too. It turns out people have been thinking about this for a long time. Greek philosophers were thinking about it. Epicurus wrote, "There are infinite worlds, both like and unlike this world of ours. We must believe that in all worlds there are living creatures and planets and other things we see in this world." And of course, people speculate as to whether if we find life elsewhere, is it going to transform our view of our humanity? Is it going to make us seem less significant or more significant? Are we unusual or common? These are kinds of philosophical things. And of course, Christian theology is going to have to embrace this. Is there a place for thinking about life beyond Earth within our faith? Billy Graham said, "I firmly believe there are intelligent beings like us far away in space who worship God, but we have nothing to fear from these people. Like thus, they are God's creation." Somebody told me they actually fear people on this earth more than beings on other creation. And then, of course, the uniquely Christian aspect to this is the Incarnation. We believe that God came to earth in human form as the center point of our faith and redemption. What would this mean to the rest of the universe if there's life elsewhere? People were thinking about this in the 15th and 16th century, it turns out, and long before that, for many, many centuries and millennia, people have been imagining this. Bruno felt that finding life in infinite worlds would glorify God, and a Franciscan philosopher, William Forlong, felt that he was thinking about, would Christ have to die over and over again in these other worlds if they needed redemption? So these are interesting enigmas. C.S. Lewis also thought about it in his science fiction novels. So in closing, I will just put out a general principle here that I like from Sir John Polkinghorne, who was a physicist who became an Anglican priest, and he wrote many good books and is still still writing and speaking, but he said that science and theology are both concerned with the search for truth. They complement each other rather than contrast. Of course, these two disciplines focus on different dimensions of truth, but they share a common conviction that there is such a thing as truth to be sought. And I like that idea. And so here we are on planet Earth. We know there's at least life on one planet, so I think that gives us the prerogative to take good care of this planet and to be curious about what may be going on other planets now that we know that there are lots of them. And I will close there. Thank you very much.
Sit down there. Yeah, wonderful. Thank you, Jennifer, so much. It's great to have someone of Jennifer's expertise. Her research has been on star and planet formation, and so to get an up-to-the-minute account is so exciting. And the discoveries that have been made, that we now have 200 billion planets that we know are out there, is just incredible. So we turn now to another expert. Dr. Stephen Freeland is here to talk about the biological side. He is the director of the Interdisciplinary Studies program at the University of Maryland, Baltimore County, which is right nearby here. His PhD is in genetics from Cambridge University, and his research is in the evolution of genetic coding, the evolution of the building blocks of life. So we have an expert exactly in this area to share about this. He presided at the Gordon Research Conference in 2016 on life's origins. The Gordon Research Conference is a very prestigious event. So I've been excited to get to know Stephen over the last few years and to encounter his faith and his humble walk with God. So we're privileged to have with us Dr. Stephen Freeland.
Hello. And right back at you, Deb. It has been such a pleasure to come to know the members of BioLogos, including those of you who I have had a chance to interact with so far. As you said, got to get going, right? But let me just put out there, since you trod a little bit into my territory, something that Jennifer didn't tell you, because I just love this when the astronomers taught me this. Imagine that our sun was a grapefruit that you're holding in your hand right now. Our Earth would be a grain of sand 17 paces away from it. Proxima Centauri, that nearest neighbor, would be a clementine in Albuquerque, New Mexico. And these good folk are building telescopes that can detect that grain of sand. That just blows my mind. Yeah, so thank you for all you're doing there. 4 years in Hawaii, I managed a team of astronomers. I don't know how I got that gig, but boy, did I learn from them. They're fascinating. I'm a biologist. Biologists love their PowerPoint, so if you thought that was heavy, sorry. Start with your punchline, right? Origins and distribution of life in the universe. I want to try and communicate to you my sense of excitement about 3 findings, very briefly. It has become so clear over the last generation that life on Earth started remarkably quickly. I don't know if you picked up a subtext to what Jennifer was telling you, but so much of this field is driven by instrumentation, improvements in instrumentation, faster and faster and better technology. And everything that these instruments are revealing isn't so much adding to our sense of our place in the universe as changing our sense of place in the universe. One of those is that life on Earth started remarkably quickly. Number 2, and this may be the hairiest one, but I want to try and communicate to you that life as we know it is built from the most obvious stuff imaginable, chemically. I'll wait till I get to that to say more. And number 3, we're discovering, again, instrumentation, that this life built from the most obvious stuff imaginable is good for an astonishing variety of environments on Earth that a generation ago we thought were inhospitable, uninhabitable. We're struggling right now to find any limits to life's existence on Earth, where it cannot be. And in fact, there are substantial overlaps now to multiple cosmic environments that we have identified in our own backyard of the solar system. So that's the talk, and we can go home now, right? Seriously, if nothing else, focus on the red bits. They're just going to tell you this all over again. On the left there, you will see a geological cartoon, the way that I was taught it as an undergrad in zoology. And the point of this slide is simply to say that that is extremely misleading. It focused on what we knew until about the 1980s. emphasizing various sort of fancy names that you may be more or less familiar with, Jurassic. But this is visible life. This is multicellular visible life. And on the right, I have put that to scale. As Jennifer told us, our planet, we think, is 4.5 billion years old. So you won't be able to read the font at the top there, but that top black box, that's where the dinosaurs went extinct. The Cambrian explosion is where multicellular life proliferated, geologically sudden. The earliest multicellular life we could find, about 730 million years ago, is that bottom of that yellow. And until the 70s and 80s, everything underneath that was just a mystery. And so on the left, you just ignore it, right? If you'll see very closely, it does admit that that is 2.5 billion years. It's just that it's squished down because we don't have anything to say about it. So the first point is that we've learned to say things about that. Instrumentation, thin sectioning of rocks, and the ability to place rock sections under microscopes, so thin that we can see microscopic fossils. Now, to be fair, this dates back to the 1950s, but papers like that were not being believed. That was 2 billion-year-old microscopic life placed on our timeline, which you'll see over and again in this brief talk. 2 billion-year-old life. 1954, and very controversial. By 2000, let alone 2011, it is abundantly clear that we're seeing microfossils, this time down at 3.5 billion years ago. Our planet has been teeming with life for a long, long time. In fact, the edge of controversy today, but even since I've started giving talks like this, the controversy is ebbing, is a more indirect way of detecting that life has been present in rocks, even if we can't still see the cells. Life leaves behind chemical signatures, and if you buy into that argument, we're now talking about life that was present on our planet, and therefore presumably prolific, 4.1 billion years ago. And let's remember that our planet was formed 4.5 billion years ago. In fact, let's go further. I'm going to skip over that one for now and remind you something that Jennifer briefly alluded to. The very process of planet formation is violent. There is such heat involved in the accretion process that our planet would have been a molten ball of rock as it formed. You get different estimates on this, but I would say a fairly conservative estimate for when our planet had cooled down enough to have liquid water on its surface would be about 4.2, 4.3 billion years ago. And now I'm telling you that as far as we can tell, life was prolific by 4.1 billion years ago. Life began early on our planet. A generation ago, we did not know that. A conservative line would have told you the opposite. In fact, some of you will remember there are variations of creationism that have picked the Cambrian explosion, the colored bars at the top there, as a geologically sudden introduction of life by special creation. 25 years has transformed our understanding of our planet's living history. And the biggest thing it's done is tell us that almost as soon as was feasible, life was here on our planet. In fact, we're running out of rocks. That was the slide I slipped over. We don't even have rocks 4.1 billion years old. We have crystals, zircons, fake diamonds. That's where we find this. Because of plate tectonics, the constant recycling of rocks, there is nothing older. So one of the less understood points about exploration of Mars, from this perspective at least, is that the lack of plate tectonics on Mars gives us a far better geological record of that exact window when we think life was forming on our planet. In fact, Gale Crater has a 4.2 billion-year-old stratum, which is being approached right now. And a lot of us are looking with interest to see what is discovered there, to talk to us more about the chemistry and mineralogy that was in fact present as life, presumably, was forming on Earth. So that's point one. Life on Earth started quickly. Point two, life on Earth is constructed from the most obvious matter in the cosmos. What do I mean by that? Well, there's a page from a book, great book, The Cradle of Life, if you're interested, a popular science book, talking about life and its early history, talking about the discovery of microfossils. Here, though, this table simply summarizes for us the chemistry at the heart of life. All that matters is the left-hand side, where you see that life, the overwhelming majority, not just of all life forms, but of all of your bodies, is just 6 chemical elements. In fact, I would argue it's closer to 4 chemical elements. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. To be fair, that was probably 1950s knowledge. There's a slew of Nobel Prizes that many of you will have studied that gave us this insight. Yeah, biochemistry is hairy, but only when you get into the details, because at its heart, it could not be more simple. And what's interesting, and I literally did not know this until I went to Hawaii, is that for the longest time, astronomers have known that those are pretty much the most abundant chemicals in the universe. There's a logarithmic scale on the left, atomic number on the x-axis, just showing you the atomic abundances. You'll get different estimates. That's an early one from 1957, but qualitatively, it doesn't change. Now, don't get me wrong, I don't like log scales either, and that's complicated, so let's do it like this. If I had 10,000 atoms at random from the universe, 9,100 of them would be hydrogen. Most of the rest would be helium. I'd get a few oxygen, a couple of carbon, and one nitrogen. And every other element on the periodic table would be less than one atom combined. And we've just said that that's what life's made out of. Life is made of the most abundant stuff that is throughout the cosmos. One other thing I should point out here, in case you were worried, aliens will not come and steal our water. Because the most abundant chemical element in the universe is hydrogen. And if we ignore helium, which I'm just going to mention for those of you who know your chemistry, noble gases cannot react in the way that we think of chemical reactions. Skip over poor helium. The next most abundant atom in the universe is oxygen. The most abundant molecule in the universe, I shouldn't say molecule, chemical compound in the universe, is water. It's everywhere. And that's what life is made out of. A lot of folk criticize NASA astrobiology for its parochial attitude, only looking for life like we know it, oxygen, water. That's why. And they're not. They're interested in exolife. But like any sensible gambler, they're putting most of their limited funding into looking for life as we know it because it makes sense. In fact, and this is a whole section of the talk I chopped out, this is my research, which I won't even go into, but is that we get much more than that for free from the universe. It is becoming abundantly clear that we get handed for free in a constant rain of cosmic dust the building blocks that are required for life as we know it. Now, I've glossed over a lot of detail there, and please feel free to ask him questions, but that interests me. I will slip in one quick theological comment. The more you study this, the more you realize that the origin of life problem is the problem of order out of chaos, not complexity from nothing. And that fits very well for me with the Genesis reading. But okay, life on Earth started quickly. Life on Earth is constructed from the most obvious, abundant stuff that is imaginable. Number 3, and finally, life on Earth could thrive in many cosmic environments. Thankfully, Jennifer has done most of my work for me here, so let's just sweep through it quickly. What conditions are suitable for life? There's Hawaii. Very pleasant from our perspective. We are something we might call mesophiles, which is just a fancy way of saying we live in the middle of every imaginable axis you could plot. Pressure, acidity, temperature. We like it in the middle. And until a generation ago, we thought that was true of most life. But again, with instrumentation, we have discovered we had it all wrong. Microbes, in the main, but they defy every expectation of what is a habitable environment. We know these things collectively as extremophiles, but they have special names depending on which particular extreme they challenge. Acidophiles, psychrophiles, thermophiles, barophiles. We have now discovered recently how much life we have accidentally already taken off our planet on spacecraft that we tried to make sterile. We can't get rid of the stuff. Life is everywhere, and to be absolutely clear, this is not life struggling to survive in extreme environments. This is life thriving in extreme environments, and arguably we are the extremophiles. The reason I say that, and I hope just give you the poster child of this, Deinococcus radiodurans Conan the bacterium. You can't kill this stuff, right? You find it growing on spent nuclear fuel. This is the sort of thing that travels up on accidental extraterrestrial vehicle that we've placed out there, right? Jennifer didn't allude to this, but one of the most edgy and surprising and, for me, exciting discoveries is that life on Earth has produced the planet we know. Things like oxygen, the water cycle, perhaps even plate tectonics or their continuance are actually products of life. And everything that you and I depend on for life is a product of earlier life. That's why the atmosphere changed. That's why the chemistry changed. That's why the geology changed. So we've talked about a habitable zone being the right distance from your star to support the presence of liquid water. That seems to be important. Water's everywhere, but is it liquid? Even by those standards, multiple planets in our own solar system were capable of supporting life at the time life was forming so readily, so easily on our planet. Earth and Venus are in the habitable zone. And more particularly, in recent time, we have, there we are, begun to notice how many additional planetary bodies there are within our own backyard that have liquid water that are capable of supporting life, even as we know it on this planet. You mentioned Europa, and we could extend to include Enceladus, to include even dry asteroids turn out to be wet, if you look at them in the right way. So the more and more, the harder we look, we're finding habitable environments. So life on Earth started quickly. Life on Earth is constructed from the most abundant cosmic stuff imaginable, and life as we know it could already thrive in a number of environments in our own cosmic backyard as we're just beginning to scratch the surface of exoplanets and exoplanetary systems. Is our galaxy teeming with life? We don't know. I'll tell you this, that in the entire history of our species, we have conducted one experiment to test for the existence of life outside of Earth. Viking 2, 1976, and the results are still debated. I can tell you that all the clues coming in suggest we shouldn't be surprised if our galaxy is in fact teeming with life. Forgive me, 30 seconds and I'm done. I want to suggest to you two questions that you might want to ask. Is there something unusual about Earth that I haven't mentioned? Well, really, that's Jennifer's domain, so ask her. Ask her about the moon, for example. Might be odd. But what kind of life does science expect is the most overlooked part of this? And I've already given you the answer, and it is so important to recognize this before we start harassing Deb about the theology of sentient life. That is not a good picture of evolution as far as we teach it today. That is actually out of a textbook, and it shows the 4.5 billion years spiraling upwards into complexity, from goo to you by way of the zoo. Now, what's wrong with that? What's wrong with that is the final product is a white male. And a white male drew that picture. That's not an objective picture of evolution. We are not an objective outcome of evolution. We are actually an outcome of evolution. But as I've pointed out to you, most of life on Earth, measured objectively, there's a genetic tree of life. We're at tippy top, okay? Most of life on Earth has been and has always been single-celled organisms invisible to the naked eye, proliferating and diversifying. Astronomy, geology, paleontology, and genetics all agree that the one story of life on Earth we know is microscopic proliferation and diversification. I belong somewhat to that body, the minority view that you may know through Simon Conway Morris. I think there probably is more direction in evolution than we have given credit for, but that is still a minority view. And I would love to answer questions about that if you find that interesting. But that's me done. Thank you, Deb, for letting me go over.
All right. So we have learned that there are lots of other planets out there, 200 billion, and some of them are habitable. We've learned that life started early on Earth, but a lot of the life on Earth is actually single-celled organisms. And we don't know how likely it is that there is life anywhere else. Haven't detected it yet. So no aliens have been found yet. Spock has not yet visited us. But we love to think about that. We want to speculate. So let's think about this. Even if we did detect intelligent alien life out there, that's what we want to think about. And this is what science fiction explores all the time. But it often leaves out a couple of things. One thing it leaves out is the challenge of communicating with intelligent life. Now, here's an exception. The film Arrival in 2016 had this beautiful exploration of how challenging it could be to connect with some other intelligent alien species, just as far as translating a language. And if you imagine trying to translate even simple communication, then what about something so complex as theology? And then, of course, there's the light travel time. So 4 light years away is the closest that we have. Well, okay, I'm getting a lot of feedback. Should I do something different? Okay. I can't talk louder. So So the light travel time. So in science fiction, they always brush over this. They come up with wormholes or some sort of portal, and boom, you're in another alien system and you can talk with them. But what we actually know is that light takes time to travel. So imagine sending a message and it arrives there 4 years later. They have to think about it, figure out how to communicate back, and arrives back here. So that's 8 years at best. Most of these systems are further away. So it's not going to be a very fast conversation. So we're going to skip over all of that and do a what if here, because this is the one we always wonder. So what if we do find a planet beyond Earth that's habitable, and it has intelligent life, so not just single-celled life, but life that is intelligent and wants to, and then we're able to communicate. They want to communicate with us. Somehow we're able to send messages, and we're somehow able to understand. Then what? What would that mean for Christianity today? So a lot of science fiction, this has often bothered me, doesn't acknowledge any organized religion from Earth, hardly at all. In fact, the only times they talk about religion, it seems to be something mystical. In Star Trek, you get a lot of discovering some primitive planet and they have some exotic religion. But talking about Christianity, Christ, or any other of the major world religions, Hinduism, Muslim, it just does not appear in science fiction. A great notable exception is this novel by Mary Doria Russell, The Sparrow. It's beautifully written, and it explores what if Jesuits on Earth were the first to discover alien life and decide to send a mission and go there, and they actually travel there, and they actually do think about if do these intelligent aliens we're meeting have an encounter with the same God that we do. Well, I would like now to consider 4 questions about what this would mean for Christianity today. There's a lot of questions around this. I've picked 4, and I'll give just brief reflections to frame our discussion together, and we will see where it goes from there. So, would the discovery of aliens make the Bible irrelevant? I have actually heard this from people. There are commentators online, atheists, who say, this is going to be the death knell for religion. If we discover intelligent aliens, that's the end of organized religion. It feeds into this idea that Christianity is parochial, that it's just this local thing and it doesn't have any cosmic significance. Tim O'Connor referred to that this morning. Christianity is just kind of fading away. Now, there's an element of truth there, but not quite the one that they're thinking of. If you think of it, the Bible is about Earth, but it's actually even more narrow than that. It's about Abraham, a certain family, his descendants, God coming and incarnating in a very small region there in the ancient Near East, walking just, not a very far distance from where he was born. And God's revelation was very particular into a particular culture, a particular place. But yet, the claims of Scripture are cosmic. In Colossians 1, it says, in him all things were created. Things in heaven, things on earth, visible, invisible, thrones, powers, rulers, authorities, all things have been created through him and for him. You get the feeling that Paul is running out of things to list, okay? He really wants to make this point. And so to me, that speaks of the Christian claims being true far beyond our own planet to encounter the whole cosmos. That the Christ that was incarnate here on earth is the same Christ of the whole universe. So whether or not there are intelligent aliens, the Bible's claims are cosmic in scope and not immediately shuttled aside. Okay, second question. Would the discovery of aliens reduce human significance? And I think Jennifer raised this one. So some people are quite worried about this. There's a feeling that if we discover other intelligent species, well, now we're one of many, and that makes us less significant. The interesting thing is, I've also heard it argued the other way. People say, we seem to be alone in the universe. We're just this very small people, and we're so small, and we're just insignificant. We're alone. So people argue it both ways. Okay, so does our aloneness make us insignificant, or being one of many make us insignificant? So science is just not a good tool for thinking about significance. That's not what we do. What we do is we measure the ratios of elements in the universe and how atmospheres change in response to life. We don't measure significance. That is a bigger question. So we need to go beyond that. And I love David Wilkinson's summary of this. This is a wonderful book by him. If you want to delve more into it, this is a great place to start. While sharing much with other life forms, even perhaps intelligence and self-consciousness, human beings are embedded in the story of God's particular acts. This is not an appeal to human superiority. It is about an exceptional relationship, but not an exclusive relationship. Human beings can be special without denying God's love and concern for other intelligent beings. So whether or not they're intelligent aliens, we are significant in God's eyes. How do we know? Well, the Incarnation is a huge clue. God came and lived here as one of us. Christ died for us. Christ sent his Spirit to live within us. These are the things that make us significant in God's eyes, our relationship with him. All right, third question. Would the discovery of aliens change our view of the Incarnation? All right, so now we're getting into some more theological territory here where Christians might disagree. In fact, some Christians seem to hold different ideas on this themselves. So I've talked about God become incarnate here on earth as a Jewish man named Jesus. Would God also become incarnate as some alien species on some other planet? On multiple alien species on multiple other planets? What is that? Really? Does that feel wrong? Does that feel right? Well, it shouldn't be about our gut feeling. C.S. Lewis has touched on this in some of his fiction writings. So in Narnia, you have the idea of Aslan, of God appearing in the form of a lion in a different world. And by the time you get to the end of the Chronicles of Narnia in the last battle, you see him acknowledging that there are many worlds and they're all pointing to one God, but God incarnate in different ways. But then in his novel Perelandra and his space trilogy, that's another wonderful exploration of life, and in this case fictionalized on Mars and Venus. And there, C.S. Lewis talks about, well, life arising after the Incarnation would somehow still look like Jesus Christ. There's some resemblance there. It has an effect on what intelligent life looks elsewhere. So the Incarnation here is somehow cosmic. I don't know the right answer to this. There's multiple options here to consider, I think is the main point. So I don't think this is a showstopper for Christianity. It is something we need to wrestle with. Christians have multiple views on how God would have related to aliens, but we do know Christ took on human form, and our understanding of the Incarnation itself here on earth is still robust. All right, fourth question, perhaps the biggest one. Would the discovery of aliens change our view of the cross? So if we're starting to think of Christ incarnate in different places, was there a crucifixion, something equivalent, a horrible death that God incarnate died for the redemption of alien life? Well, there's a nice new book out from Vanio, and he gives this nice summary, and I'll just read it to you. He proposes 4 possibilities for how we could think about our view of the Incarnation and redemption. So A, perhaps aliens are not fallen and they have no need for redemption. So it could be that they made a different choice. Whatever their equivalent of the fall was, they did not rebel and choose sin, and so they don't need the redemption. Okay? Or maybe B, aliens are fallen and they have their own way to God, which is different from ours. So we don't know how God would choose to relate to them. In fact, we have a couple of different models in Scripture, how God relates to animals. Well, he cares for them, but God didn't become incarnate for them. We have how God relates to angels. They actually fell, but there doesn't seem to be a salvation plan for angels. Some of them fell. And so it does seem to me that God's plans for redemption and how he relates to people can be different for different kinds of life. Point C, aliens are fallen, but they're included in Christ's redemptive work on earth. Lutheran theology that is so centered on the cross of Christ sometimes goes this direction of saying that Christ's death was cosmic, and in some sense, just as Christ's death in the Middle East applied to people all over the earth, well, maybe it also applied to alien life. So that's another option. And point 4, Aliens are fallen, but their nature is assumed by God in an act of incarnation and redemption in their own world. So this is the idea of God being incarnate and being crucified on other planets. So that's only one of these four options. Is your head spinning yet? I've been thinking about this for a while, and I still can't get my head around these, like even what all the pros and cons are. I welcome your questions on this. I think what we need to remember in this is that God's character is still the same. He'd be the same character of love, the same desire to be self-sacrificial, the same desire to redeem people to himself. So while Christians have multiple views on God relating to aliens, we know that Christ died to redeem human sin. So we should ponder the tough questions. We should wrestle with them. We should be thinking ahead, okay? So we haven't discovered alien life yet, but for once, Christians don't have to be behind in thinking about what theological issues are coming down the line. We can be thinking ahead. And we can be curious. I'm so excited to learn what are the next discoveries going to be. And we can be celebrative whatever we discover out there of life, whether it's microbes or intelligent creatures, creatures that mystify us. We know they are created by God, and we can celebrate that. Thank you. Let's see, we'll advance one more here. So I'm now inviting up our other two speakers. So instead of table discussions this time, we decided we'd have a little dialogue between the three of us. Since you've heard multiple speakers, we'll interact a bit, fill in some questions, maybe ask each other some questions. And after a few minutes of that, I've got my phone, so I'm ready to read here the questions you are submitting. So keep submitting those, and we'll feed those into our discussion as well. So, all right.
I'm glad you figured it all out.
Yeah.
Just
There won't be any questions because everything is so crystal clear.
crystal clear that we have no idea on most of these questions. But I did want to give it some of these grounding points that we can hold to even while we're discussing the rest. So you've both thought a lot about this. Would you like to chime in on some of these theological questions?
I would like to chime in on a scientific, well, it's something that touches both on the science and the resulting bigger questions, but it is the tendency that we all have to jump to the questions of, the intelligent civilizations that we may encounter and what is their spiritual perspective and all of that. And that is intriguing. But from a scientific perspective, we are really more likely, if we detect signs of life at all in the next century, it will be likely simple life, microbial life, single cellular life, simple life. You would be able to address this better than I. But so I think we don't think enough about the significance of finding even simple life beyond Earth. How would that shape or affect our faith and our understanding? Would this concern us that however life began here, however God created or started life here, there were other processes that God is using elsewhere? Is that something that we're ready to celebrate or perplexed by? So these are the kinds of things I think we shouldn't skip over in our desire to think about meeting the advanced civilizations as well. So I'd be curious to know what folks think about that as well. So
That's a good question.
Yeah.
I remember NASA telling me, and forgive me if you know this better than me, that a survey they'd recently been involved with, asking people of faith, people of no faith, what this would do to your faith. The overwhelming discovery was that everybody thought it wouldn't be a problem for their own faith, but it would be a problem for everyone else's faith. And I don't just mean denominationally. I mean, my faith is intact, but I'm worried about you as other Christians. I thought that was telling, and I think that it's a non-answer. But you know what? If we're here, we love God, God is central in our lives, and we check in occasionally whether our conversations and our actions are reflecting the fruits of the Spirit. I don't really mind where you're all at with it, but I'd love to hear.
that was Ted Peters,
Thank you.
the theologian who conducted the survey.
Thank you. Sorry.
But you're exactly what he found was that no matter what people he asked from all types of faith traditions, Christianity and other faiths, if discovering intelligent life would really upset their faith, the foundations of their personal faith. And everybody said no, when they reflected on it, they could embrace it. But just as you said, when they were asked about how other people would react, they all said